Life consists of a continuous dance. Movement is part of our reality and perception. The interactions of our surroundings set the pace of the continuous cosmic dance. Even in the simplest objects like toys we found the beauty of existence expressed in mathematical language. This time, we will explore the movement of a toy train. The purpose of this experiment is to analyze the physical principle of Newton's second law applied to a toy train that moves without changing direction. For this experiment, assuming that the sum of the external forces to the system is zero, I place the positive x-axis in the same direction of movement, which guarantees a positive speed. Starting from the basic definitions of average velocity, acceleration and force, the equations are combined to express the acceleration in terms of strength and mass. This data was obtained from the tracker. We take the first-to-time data and position to determine the average speed. We determine the average velocity, that in our case is 0.21 meters per second, in addition to the final time of 1.33 seconds to indicate vital, the end of the cycle. In the extension of script vital I put an estimated value of the mass, but this is irrelevant because if the net force is zero, then the mass does not influence the study. The initial position of the particle is at the origin of the Cartesian system 0, 0, 0. The average velocity is 0.21 meters per second as already calculated. Little delta to ensure Newton's force equal to zero. The end time of the program marks the limit to make the loop the force was applied as the top is null. The general expression for the position in time, the general expression of the speed in time. When you run the script, you have the model of a particle moving from left to right with constant positive velocity. When we graphically compare the theoretical model with the experiment, this are the results. Both plots are straight. Also shows an experimental variation since it is not in fact satisfied that the sum of the external force to the system is zero. If the orientation of the axis were reversed, the speed increase would be negative and negative position in time. The time variation should be small, assuming that the net force is zero, almost instantaneously, indicating that the rate does not change much in a small space of time. The sum of forces is equal to zero. The experiment shows that there are no elements such as friction, vibration on the rail train, inclination on the table, and the friction that makes a small difference between the two models. Newton's first law indicates the presence of inertia in the system. A fundamental physics principle studied by Galileo was the key to understanding the movement as we know it today. Even the movement of a small child's toy